All right, welcome back. It's currently day 7, and we're going over scripting today. So I've been reading up on scripting on the website Made.md. It's actually a really good website. It has a lot of good resources about ML ops. So I'll copy and paste this into the chat if you guys want to check it out. But I think generally, like, it has very, very good information about ML ops, and it's very easy to follow as well. Okay, so let's take a look at today's goals. Read topics under scripting from Made.md. That's what I'm currently doing at the moment. And apply the learning by adding it to current projects. Okay, I'm not sure if we're going to be able to apply everything, just because we've already created the applications and changing it would require a lot of work. But I think for the most part, we could add documentation and styling and maybe like a Makefile and stuff like that. So first things first, organization under scripting. So organizing our code when moving from notebooks to Python scripts. Notebooks are generally Jupyter notebooks and stuff like that, .ipynb files, which are really easy to code Python with. And if you use Jupyter or Google Colabs, this is what you're usually doing. But what we want to do is convert it to Python scripts, because in an ideal scenario, when you're working in a company, they don't really use the ipynb file for production environments. They use the .py file. Okay, so let's see here. To have an organized code is to have readable, reproducible, scalable, and efficient code. And we're going to look at ways to organize our directories. So there's several ways to organize the code from notebooks, but they're all based on utility. And so usually this is what is called like a pipeline. So we're going to base it on the pipeline components. So usually there is data pre-processing, the first step. Then there's training, evaluation, and then finally prediction. These are like 4 simple steps of the machine learning pipeline. But of course, there could be more or there could be less, depending on how big your application is and what your application is doing. So here we have the config file, the configuration setup, the data pre-processing, which is data.py, evaluation, the main.py, which controls pretty much all of these other pipelines, the model, which contains the model architecture, prediction, training, and utilities, maybe other supplementary utilities. Not too sure what the difference between supplementary utilities and configuration setup is. 1 second, I will be back. All right, let's see, where were we? Reading. Another way to supplement organized code is through documentation. All right, we'll get to that later. Don't worry about what all these scripts do just yet. We'll be creating them and going through them in subsequent lessons. I mean, for the most part, you guys should know what the ML pipeline is. For usual model prediction, model training, this is what the pipeline is. Processing, training, evaluation, and prediction. All right, so reading. We could take a look at documentation, blah, blah, blah. Dive deeper into specific workflows a little later. Operations defined in the main.py. So I'm assuming run is within main.py. This is responsible for training. And so inside training, we would set up, load the dataset, prepare it, pre-process it, and all of these different steps within run. I think this should be contained in main.py. And we can go check out his code base. Let's see here. So yep, this is main.py, and he has a run function in here. And it has a lot of code. So immediately what we could do is check out, okay, what are the input parameters? He has namespace, and he returns artifacts to save and load for later. What does that mean? Wow, this is... Okay, this is what I'm trying to learn, actually. Set the seed. Set device. Load data. Prepare it by future engineering, filter, and clean. So he's calling data here. So all of his like code is sectioned out into different files, and you can see that here. So his data evaluation. This is what beautiful code looks like when it's segregated into different files, and it's very dynamic. Preprocess encode. Oh wow, I mean, if you take a look at what I've been doing so far, it's just shoving everything into one file. I mean, I don't even have this finished. I just used the IPYNB file, and I think I accidentally deleted it. Whoopsie daisies. Yeah. Oh, that's annoying. So yeah, it's very important to organize your code, I guess. Let's go back to organization. When looking at the code base at first, it's good to create a mental model of the entire application and writing it down for yourself so you can easily navigate it in the future. So maybe when you're creating like a model or a project, have an idea of like what your pipeline looks like based on whatever model you're developing and what your app is kind of like. So I guess if we look at his app, we should be able to see how the application will call the model itself. So if we go to app, API, this is the backend, which would call his model. So he's using Flask here, or is it like Fast API? Must be some variation of a front-end application device. Application library. So it's kind of the same thing. You get a response.get, sends a get request, I believe, and then it performs the code inside here. Params, predict. This should be the main prediction. Predict.predict. So where's predict? It's the CLI. Oh my gosh. This looks like a lot of code to go through. Let's go back into the model. JSON. Where were we? Oh, here. This is, well, why is it called added augmentation? Tag IAF. So he has his app and he has his tag. Wow. This is so neatly organized. I mean, this is what a repository should look like at the end. I mean, if your repository looks like this, your recruiters go through your repositories, this is heavenly. Okay, I mean, all right. What's next? Packaging. using configurations and virtual environments to create setting and reproducing results. So it's integral to consistently to be able to consistently create an environment to develop so we can reliably reproduce the same results. So no matter what computer you're on and what user is running your model, you should be able to get the same results from the model. So one way is using Docker. The other way is setting up a virtual environment using Python. So we can create a setup.py file, create a requirements.txt, which should contain all of the libraries we're using and the versions. And in addition to just the requirements, we could also include some packages required for testing and development. So this is pretty cool because what they say here is you could add GitHub Actions, and it automatically tests your code every time you push into GitHub. And all of that would be separated from the dev packages and test packages. So the heart of setup.py file is the setup object, which describes how to set up your packages and dependency. Okay, so we have an object called setup, which describes the package and its dependencies. First several lines cover metadata, name, description, etc. Then we define the requirements. Here we're starting with stating that we require a Python version equal to or above 3.6, so that's here. And passing in our required packages to install requires. Required packages, and I'm assuming required packages is this stuff right here. The libraries from requirements.txt, okay. Extra requires, and we can have our test and dev packages. Okay, entry points. The final lines of the file define various entry points which we can use to interact with the application. Here we define some console scripts we can type on our terminal to execute certain actions. For example, after we install our package, we could type the command tag if AI to run the app variable inside. That's pretty neat. So I guess he's setting up like commands, like shortcuts to commands. Console scripts tag IAF is equal to tag AIF.main app. And let's go through his repo once again and check. So app CLI py. Yeah. And it should call app, run app variable inside here. App. So the typer is a CLI app. What is typer? Import typer. Library. Library for building CLI applications that a user will love. Okay, so Fast API is a little sibling. But what does it do? CLI applications that, okay, it's the same thing. Defines a standard notion for a Python function and variable type annotations. For documenting code, and also used by static and runtime checkers, static analyzers, IDEs, and other tools. So I guess it's just a CLI, building CLI applications. We have to learn more about what CLI is. Command line program. Okay. That accepts text input to execute operating system functions. All right. So it's just your terminal. Command line input was commonly used by Unix systems and PC systems. Yep, it's pretty much your terminal. So we could build CLI applications using Typer, and that's what's happening here, I guess. App.command, and these are all commands. Train model, predict tags, and all of that stuff. That's nice. That's neat. So basically, when you kind of download his application, if you're a developer or something, you could type in a custom CLI or whatever command he creates, and you could enter it into the terminal, and that command would be known. For example, if you typed in download data, it would run this function right here. That's pretty neat. And okay, so one of the commands that he's setting up entry points to is to run the app variable inside this. Search up our app. What does he mean by app variable? Tag main dot main app. I think that's just pretty much it. I mean, I don't know. I don't know if there's anything extra. I mean, if you type in train model, it should run the model from main.py. Trains it. Okay, what else can we do? Usage. We can install our package for different situations. So install E installs only required packages. So you could specify dev and test. Nice, okay. There are many alternatives to setup.py, such as the setup config, and more in recent, increasingly adopted pyproject.toml. So I guess there's different formats, and this is just one of the formats that we could specify. Setup.py. All right, let's move on to documentation. And I will be back again. All right, I'm back. I should create like an AFK transition or something to indicate that I'm currently away. Okay, let's see, where were we? Documenting code. Documenting code for your users and future self. Okay, so code tells you how, comments tell you why. Ah, nice quote. Another way to organize our code is to document it. Okay. We want to do this so we can make it easier for others and ourselves to navigate the code base and build on it. We know our code base best the moment we finish writing it, but unfortunately, documenting it will allow us to quickly get back to that stage and time again. Documentation involves different things to developers, so let's define the most common and required components. Components, terse descriptions of why a piece of code exists. Typing, specification of a function's input and output data types, providing insight into what a function consumes and produces. All right. Docstrings, meaningful descriptions for functions and classes that describe the overall utility, as well as arguments, returns, etc. How is this different from typing? Functions, inputs and outputs, and output data types. So I guess when he says function, does he mean the entire, I guess there's some overlaps between docstrings and typing. Documentation and render web page that summarizes all functions, classes, API calls, etc. Cool. So check out the auto-generated documentation page for our application. And so I guess this is his documentation page, which is automatically generated from his for his code base. Wow, this is neat. Hosted on GitHub.io. But yeah, home, getting started, reference. Look at that. Everything built from documentation that's provided in the code automatically. Okay, so typing. It's important to be as explicit as possible with our code. We're already discussed choosing explicit name, variables, functions, etc. Another way is by defining the types for our functions, inputs, and outputs. We can do this so we can quickly know what data types a function expects and how to utilize it. Okay, so far our functions will only look like this. Pretty regular. You have a function name, some parameters, and a return. But we can incorporate much more information using typing. All right, cool. So sequences, he gives a name to the arguments, sequence, max, sequence length, and he specifies it as an integer, sets the initial to 0. And this arrow mark, I think it's just meaning that it returns a, oh, there's definitions here. Defining our input argument sequences is a NumPy array. Sequences is a NumPy array. Okay. Max sequence length is an integer with a default value of 0. And our output is also a NumPy array. There are many data types that we can work with, but we're not limited to in all the different data types. Cool, cool. And you can also define classes as types. Okay. So we can return a class as an object and specify that as the return type. And a cool example would be kind of like the TensorFlow database in GitHub. I mean, if you go through their code and see how it's organized. For example, let's go through their Python and something like shoot, I don't even know where to begin. Layers. Oh, this is just full imports. Maybe choosing TensorFlow is not the good idea. Go to add-ons. TensorFlow add-ons. I know that this repository better, so we could go layers and then kind of just look through how they wrote their code. So they specify the data type, stuff like that. They have classes, and within classes they have doc strings. They have examples within the doc strings. And all of this gets rendered onto their website, TensorFlow. So this website and all of the APIs built, like all of this is built using the doc strings that they specify here, which is really neat. So if you make changes to this code, if you make changes to like this input shape, it would reflect on their website whatever you go. For example, bitwise and. You would see arguments. So if you make changes to the code over here, it would reflect onto the website. It's pretty neat. So we can specify the return types. Next is doc strings. Make our code even more explicit by adding doc strings to functions and classes, arguments, returns, exceptions, and more. Okay, so we gotta do this to all of our code now. Different parts of this function's doc string. So first we have a summary of the overall function. Next we have an example on how to use a function, usage. And this is just these 3 tildes indicate that it's code, and Python means it's Python code. Not sure what this pre does, but it probably formats the output. Example, and then we have an insertion of a note, line 18 to 19. So we have a note, arguments, raises, and returns. So let's write this for maybe some of our applications here. Okay, this already has. Let's go to this Flask app. So for our predict function, we can write our doc string. The predict method, what it does is, what does it do? What's a good definition for this? So loads in trained model and performs prediction using user data. And then usage. How do we use this predict method? I guess it's just like you can't really use it. It's just called when the URL is changed. But what else can we include? We can include arguments. Args. And then what are arguments here? Nothing. So we'll just say none, I guess. Raises. So it raises an exception and a value error. So you can write value error if the input does not meet data type requirements or something. Yeah, I mean, if you enter in a string, we can't input that as a float. Okay, next, returns. So we return a render template object. With the predicted values. So this pretty much creates an HTML. And I guess this would be a very basic docstring for this method. mkdocs. So we're going through all of this effort to include typing and docstrings. Wait, hold on. Where's typing? Oh, and typing is just indicating like our data types for return, and I guess here we don't really have any arguments, so we can skip that. Let's check TensorFlow. Do they specify their return type in their classes? Not really. Yeah, they don't really specify their return type. But they do set like names and stuff for their arguments. So that's docstrings, and let's take a look at mkdocs. What if we can collect all of this effort and automatically surface it as documentation? That's exactly what we'll do with this open source packages. mkdocs generates project documentation, required plugins, styling, fetch documentation automatically from docstrings. Okay, so we first create a mkdocs.yaml file. Let's do that. mkdocs.yaml. Let's check out in his repository where he puts that YAML file. It's in his root directory, so that's good. Okay. Fill in metadata, config, extensions, and plugins, and more setup options like custom styling, overrides, etc. And he has a custom CSS to make everything look nice. Okay, I mean, we don't have all of that cool stuff, but we'll probably have a very basic one. So we could specify site name. So first our project information. So site name here, I could call it, I have no idea. Not very creative right now. Gap. Site URL, which we don't really have because it's not deployed. Site description. Deploys linear regression model. site author. That would be me. Next, our repository information. Repo URL. And we could go to our GitHub and get that real quick. I mean, my GitHub. If you guys are following along, you would probably want a link to your GitHub repo. Repo name 100. Oh, okay, it would be this end part. Disable edit buttons. Edit URL. Is that URI? URI. Disables edit button. Add logo and favicon. We're going to pass on this. I don't really have an image. Fill the navigation in ML docs. It's a page tree. And we'll have something very basic. Navigation, and we'll just have home, I guess. Oh, and then you have to have all of these markdown files for each of the locations, I guess. But for us, I'm just going to specify it as the README, which I guess does not exist here. Okay, I guess we'll have to create a README. And we could specify that as README.md. That's enough for us. Let's take a look at his, where does he have all of his markdown files? So he has it under a folder called docs. That's cool. It's got the CSS and all the images. And all the markdown files. And you could specify like the location as well, so it doesn't really matter if it doesn't really have to be in the same directory. But his YAML file is here, so how is he accessing? Let's take a look at his YAML file. So his page tree right here. Specifying all of the markdowns. But why is it he didn't specify docs? Interesting. You could specify social media and stuff. Copyright. Yeah, so he didn't really specify like for the location exactly. He just said index.md and it was able to find it. Interesting. Not too sure how that works. Fill in the plugin informations. Rerun, make. Install dev. We can add our own. What's going on here? Add tag fai.data markdown file to populate it with the information from functions, class, and docstrings. Repeat for the other scripts as well. Okay, I'm not sure what that means, but we could try creating the docs. We'd have to seed into the MK docs. What's going on? Python -m MK docs. Serve. No module named MK docs. Do I have to pip install? Okay, I mean, that should work. Building documentation. What's going on here? mkdocs.yml. Okay, this is a YAML, which should have been a YML. Docs directory. What's going on here? The path docs is in an existing directory. Oh, so it defaults when we specify navigation, it defaults to docs here. Okay, let's do this. Let's do this for 100 days of ML, not a subdirectory itself. So what I'm going to do is I'm going to move this to my root directory. Okay, so next what I'll do is create a folder and I'll call it docs. And then inside docs, I can specify, I guess, my files. So first here, I guess I'll call home instead of the site name. I'll call it 100 days of ML part 2. And I'll name this the same thing, 100 days of ML part 2. This will be index.md. And then here we could have index.md, but we can leave this empty for now. Or we could kind of copy paste the same thing that's in README here. Boom, boom, boom. And all right, what's going on here? Oh, days. I need a CD back here. Nice. And I guess it's serving on port 8000. Wow. Nice. Okay. Cool. So we can see here, it logs it really nicely. All of this gets automatically deployed. Right now it's deploying on localhost, but if you do have a URL or a hosting, you could specify the URL and it would serve on that URL. View a render documentation on GitHub Pages. So he's using GitHub Pages to host his. So yeah, that's how he did this thing. And you can add CSS to make it look nice. I didn't add any CSS, so it looks like this. Awesome. Could also add stuff like copyright and social media. He also specified configuration and stuff like that. It's pretty cool. Extensions, plugins, search, macro, mkdocs, CSS, and JavaScript. Okay, so that's documentation. Let's move on to logging. How are we doing on time? We're an hour in. Almost done. Got only 3 more sections left. Okay, logging. Keep records of important events in our application. Logging is the process of tracking and recording key events that occur in our applications. We want to log events so we can use them to inspect processes, fix issues, etc. All more powerful than print statements because they can allow us to send specific information to specific locations. Not to mention the custom formatting. Share interfaces with other Python packages. So we should use login to provide insight into internal processes of our application to notify users of important events that are occurring. So different components, we have logger, handler, formatter. Main object that emits log images from our application. Okay, handler used for sending local logs. Formatter, style, and so much more. Filters, exception, etc. Levels. Before we can create our specialized configured logger, let's look at what logger messages even look like. Huh. Alright, so this is kind of what it looks like, logging messages. Oh, and this is what shows up on the terminal. I mean, if you look at here, these are logs. Info, blah, blah, blah. So info here, info, stuff like that. So cool. And I think I saw a glimpse of this in his repository as well, somewhere under app and CLI. Yeah, logger, info, and data download. Okay. So it would show up as info, and then his message would show up here. So that's logging. Basic levels of logging. Alright, so the different levels. We have configuration, config.py. These loggers are more useful for our application. So we have a bunch of different logs here. Version. We have handlers, loggers. What's all this stuff? Console info error sends log messages. std out stream. Sends error, sends info. Okay, they're just different, I don't know, different ways to send out logging information, I guess. Man, this stuff is not very intuitive. Oof. Guess this is all of like the boring part of CS, where you have to kind of just like format your code and make it look pretty. Not the actual code, but just making it like nicely, well documented. When users really use huge applications, you want it to be really well scripted, I guess. Because if I was using a library, I would want it to give me really good information neatly. Like stuff like this is pretty nice. So I guess it makes sense that it's really important for us to keep this in mind, especially when we're building a huge application. Boom, boom, boom. So I guess this is just different colors and stuff. Here it's loading in the configuration here. Login config. Login config. And we can specify the formats and stuff. Okay, so here we can see green, blue, all of this stuff gets formatted from looking like this to looking like this. I guess that's what the login config does. Nice. And you can also specify a lot like file names and include extra stuff, so it becomes easy for them to debug their code. We could also check our log and error log to see the log messages that should go to each of these files. We should be seeing more informative messages there. Okay. Let's keep it going. Yeah, styling and Makefile left. Styling and formatting code. Make it look consistent. Code is read more often than it is written. Nice. Author of Python. It's almost never the last time we see it. Last time it's edited. We have to explain what's going on. One of the easiest ways to make code more readable is to follow a consistent style and formatting convention. So this is kind of like a Python format style convention. It's a style convention. Everybody's consistent and following the same convention. There are pipelines in place to ensure that consistency. So tools, we have black, insert, and flake8. So all of this stuff, I mean, if you're gonna contribute to TensorFlow open source, like I learned this by contributing to TensorFlow open projects, like add-ons and stuff. So what's black? An in-place reformatter that adheres to PEP8. Insert sorts all formats, import statements inside Python scripts. Flake8, a code linter with stylistic conventions that adhere to PEP8. We install all of these as they were defined in out setup.py file under dev packages. I think I have it globally installed, so that shouldn't be a problem. Okay, configuration. Before we can properly use these tools, we have to configure them because they have discrepancies amongst them, since they follow slightly different conventions that extend from PEP8. To configure black, we could pass in options using the CLI method, but it's more efficient to do this through a file. So we'll have to create a pyproject.toml file. Where did he place this file? Okay, that's in his root. So we'll do the same thing. in our root, new file, pi project.toml. And this will be for black formatting. Specify the tool. What's the line length? Include, exclude. We'll just copy and paste the same thing here, I think. I don't really have any preferences. It was created to establish more human-readable configuration file that is meant to replace a setup.py or setup config, and increasingly widely adopted among many open source libraries. Yep, I can testify for this. Maximum line length should be 79 characters. Include certain file extensions. We're going to do the same with isort as well as flake8. So I'll copy paste this. Tool is isort, profile, black formatting, same line length, multi-line output, 3 lines, comma trailing comma, skip get ignore, virtual environment. We don't have a virtual environment, so I think we'll get rid of that. Next, flake8. Exclude v&v, we don't have a virtual environment. Ignore, I don't know what this stuff is. Let's look at it. Complete list of configurations. We've decided to set these explicitly. Lastly, it's flake8. Here we're setting up configurations like before, but including an ignore option to ignore certain flake8 rules. And these are the rules we're ignoring. Line too long, line break occurred, missing white space around arithmetic operators. We can also choose to specifically ignore certain conventions on a line-to-line basis. Interesting. Imported but not used. Oh, okay, so in our like code, we can specify like what to ignore. Usages. To use these tools, we could run these commands individually. The dot signifies the configuration file is in the current directory. Okay, so let's do that. So we can do black dot. Okay, maybe I haven't installed black globally. But I think I created like a virtual environment or something. So it's downloaded in the virtual environment. It's always good to create a virtual environment. I probably should have done that for this. Boom. Okay, black 8, and then let's try flake 8. Okay, flake 8 worked. But there's a lot of errors. The black dot. Okay, 5 files reformatted. Awesome. Flake. We can do flake 8 now. Wow. I mean, we could fix all of this stuff, but or we could just ignore it, which is what I'm going to do. Insert. I don't think I have insert. I have to do sudo install. Oh, it's not insert, it's isort. Sudo apt install isort. And let's run that. Isort period. Unable to parse file. is a directory. I mean, yeah, it is a directory. But shouldn't it go to my file here? Did I specify isort? I did. Tool.isort, tool.black. I also have flake8. Well, there's nothing on the internet for this. I'm not sure. Do I have to specify the file for this? What's going on? We could run the commands individually, but we can also use the style target command from our Makefile. I guess we're going to learn about this next. Makefiles. Intuition, okay, an automation tool that organizes commands for our application processes. Keep track of. To help this, we're going to create a Makefile, which is an automation tool that organizes our commands. This makes it very easy for us to organize relevant commands, as well as organize it for others. Inside of our Makefile, we're going to see a list of rules. Rules have target and prerequisites that need to be met. Targets. Execute any of the rules by typing make and then target. Interesting, okay. View all the rules inside our Makefile. Our recipe, which specifies how to create the target. Okay. Alright, I mean, all of this stuff, it's not really for me. I didn't really include a virtual environment, but if you did, you could add this to your Makefile. Phony. A Makefile is called... Traditionally, the targets are supposed to be files we can make. However, Makefiles are also commonly used as command shortcuts. If you call your directory call docs and a target, your Makefile call docs, when you run make docs, you'll get this message. Look, docs up to date. Oh, this is if there's similar names, I guess. Okay. Variables, we could say variables. Let's check out his Makefile and see what he did. Where's his Makefile? Phony help. And then he has help. Let's install dev, docs, how to use the app and stuff. Okay, that's pretty cool. It's got a lot of stuff. Alright, alright. I don't know if I can include that. Alright, I mean, we'll learn a lot of stuff today. I feel like it was very boring. But gotta know all these things. especially if I want to contribute to open source and want to create like production level and code. For sure, this is very common in a lot of the companies. Oof, I'm glad we got through that, but gotta keep practicing. Gotta keep applying these things we just learned. Otherwise, it's no use just reading these things. Okay, let me take a step back and go over what we did today. So I think we met our targets for today. Gotta set up goals for tomorrow. Can we check off anything? I don't know if we can check out ML pipeline. We just only learned about scripting, so I'll leave this here. Boom, boom, boom. Yep, that's good. What I could add here is I learned scripting. Actually, I don't want to add that as a challenge goal. I'll leave that out here. Or should I actually add it? I don't think I'll add it. Learn about scripting for MLOps. Goal complete. And okay, so goals for tomorrow. I think I'm going to start on a new book. I've been looking at reinforcement learning recently. I think I bookmarked this book by Tom Mitchell, a very popular CMU professor. This book is called Machine Learning. It's an introduction book. Very nice. And I think chapter 13, when it loads, is about reinforcement learning. So I'll be going over that to complete my reinforcement learning topics. So tomorrow is going to be a whole lot of reading and learning. So let's see. I'm going to start with this book. Let's just go over introduction. Boom, boom, boom. All right, I think I can read introduction tomorrow. Pretty good. Yes, and then I'll also read TensorFlow Extended. Okay, sure. I'll read the first 2 chapters. Reading. This reading. I don't know if I want to do reading on stream again. It's gonna be very boring. But I need to get this done, so we'll leave it. Boom, boom, boom. And our goals for tomorrow should be finish chapter 1, chapter 2. Chapter 1, introduction, and chapter 2, introduction to TensorFlow Extended. Oh, all right. We're progressing. Yep, this is what I was talking about. Gotta start reading chapter 13, which is about reinforcement learning. And they also have CMU notes online. And if you also want to follow the course, you can do that on YouTube. They upload the lectures, which is pretty neat. So I recommend if you guys want to follow lectures and stuff, recommend checking out CMU or MIT lectures for deep learning. Those 2 are really good. Cool. And we can update our push code to our GitHub repo. Once I save this. Is that it? Is that what we're doing? And maybe we'll give a title for day 8, day 9. Okay, since we've been covering a lot of theory, kind of want to do some coding on day 9. But I don't know. Do we have any code examples? There's some code examples here. We could try this stuff. Data ingestion. Like all this stuff is just snippets. I'm not even sure how we're gonna try to learn it. Okay, I'll try my best to code these snippets, but it might take a lot of time. So I'm not sure how long this is gonna take. Chapter 1 and 2. I guess we'll progress with chapter 3 and 4 next, data validation and data ingestion. Okay. I think the next few weeks are going to be like this. Chapter 3. Data ingestion. And then read chapter 4, which is data validation. Okay, cool. And I think in the future, if I do get bored, I might just create a small project and really apply everything that I've learned so far, like scripting, Kubernetes, and Docker, and create another folder for that. We'll get to that when we do. We have 100 days, so there's no real rush here. Okay. I will just commit my code to GitHub now. How do I remove this from untracked files? That's so annoying. Let's git add docs, git add mk docs. What was it? Day 7. We did not. Gotta git add readme stream that. All right, we updated our readme. Nice. Oof. Sheesh. All right, that's the end of this stream. I'll be back for tomorrow with a lot more reading, and hopefully I do not get bored. Let's do this. 7 days done, 93 more days to go. Take it step by step. All right.